Willkommen zu Nick Does Maths. We're going to do some more maths here, and actually this is first of two videos where we're going to approach this in two different ways. Once in a fairly hardcore, normal mathsy sort of a way, and then we're going to use quite a cool little identity in the follow-up video, so stay tuned for that. So we need to do this integral. Now, sine of 9 over 2x, sine of a half x. Well, before we go any further, what's jumping out at me here is the fact that, and we're going to be doing a lot of trig identities today, sine of 9 over 2x is sine of 4x plus a half x, which is sine 4x cos 1 half x plus cos 4x sine 1 half x. So already, right, we'll do the integral right at the end. I can see that sine of 9 over 2x times sine of a half x is equal to sine 4x, and I'm going to write this as cot half x for now, plus cos 4x, and that's quite nice. Now really what we've got here is we are dividing by sine of a half x, so what I'm going to try and do is I'm going to try and get from a sine 4x to something with half x's in it. And we're just basically going to use our double angle formulas again and again and again. Now I'm going to leave that as is for now. And then sine 2x is 4 cos x cos 2x. And we're almost there. So this is 8 sine half x cos half x cos x cos 2x. We're getting this really funky sequence going on here. But now I've got what I need. Okay, now I'm starting to get what I need. So bear in mind, we're going to be jumping around a little bit. We've got this locked in, right? We've got this locked in. So I can already pop it in here. And I'm just going to leave it for now, so I don't have to worry about it too much. Okay. All right, so this tells me, of course, that sine 4x cot half x is this divided by sine times cos. So we end up with 8 cos squared a half x cos x cos 2x. And believe me when I tell you, this is going to get weird. Now, we're going to use and abuse today our identity cos of 2a is 2 cos squared a minus 1, i.e. cos squared a is equal to cos 2a plus 1 over 2. We're going to use and abuse that. All right. So this cos squared becomes cos 2 times a half x, which is cos x, plus 1 over 2. Times cos x, cos 2x. Now the more eagle-eyed will have spotted that I can already do some cancelling there. Now what do we get here? So we're going to move up to here. So we're still working on this term here. This is the term we're working on. This one we've locked in, that's fine. This is the term we're working on. So this is where we've got to. So if I were to multiply this out a little bit, that would become 4 times cos squared x plus cos x. I need a little bit more room, don't I? We're going to come off camera. Becomes 4 times cos squared x plus cos x cos 2x. But cos squared x is cos 2x plus a half cos 2x plus 1 over 2 plus cos x times cos 2x. Don't know why that bracket's there, don't know why that bracket's there. It's getting intense, y'all. So we end up, if I expand all this out, I end up with 2 cos squared 2x plus 2 plus plus 2 cos 2x plus 2 cos x cos 2x. Oof, a little bit tight there. Right, now, this term here, happy as Larry. I can include that, not a problem. Not a problem. This term here, bosh, let's add it in. All right, we're going to have to make a little bit of room here. So actually, let's start collating this over here. Let's start collating this over here, because that is not going to work for me, is it? 1 over pi minus pi to pi. So we've got that cos 4x that we've already played with, and that's nice. We've got that 2 cos 2x there, so that's nice. And now we need to deal with the rest of it. Now we need to deal with the rest of it. All right, we're going to use another identity here, which is kind of cool. It's this. It is this one here. It's that cos a plus b plus cos a minus b is 2 cos a cos b. Check that one out, just your double angle formula or your addition rule. Cos of a plus b plus cos of a minus b is 2 cos a cos b. That's what we're going to use there. This one here, we're going to use that one. So this term here becomes cos 4x plus 1. That one we've already done. And that one there becomes cos 3x plus cos x. And that should be a 4 here, shouldn't it? That should be a 4. So it's going to become 2 and 2. All right, so let's put all this in. This cos 4x is going to give me a 2 cos 4x. So I've now got a 2 cos 4x. I've got a 2 cos 3x. I've got the 2 cos 2x I had from earlier here. And I've got 2 cos x. And this is what my integral has become. Kind of neat, right? We used a whole bunch of multiple double-angled formulae to get down, and then we use them to get back up to this. So really, I'm missing the plus 1. I'm missing the plus 1. Again, let's tidy that up just a little bit. So that is 1 over pi, the integral minus pi to pi, 2 times cos 4x, cos 3x, cos 2x, cos x plus 1 dx. So now we need to integrate that. Well. Cos 4x between minus pi and pi, what's going to happen there? We're going to have to do this. Let's pull, no, let's leave the 2 out. So this becomes sine 4x over 4. This becomes sine 3x over 3. Becomes sine 2x over 2. Becomes sine x, and then that becomes x. All right. What do we get? Let's plug in pi. Sine of 4 pi is nothing. Sine of 3 pi is -1. Sine of 2 pi is nothing. Oh no, these are all nothing. They're all nothing. They're all nothing. Silly boy. So we end up with pi. And then we'll add in the minus pi. So end up with 2. And again, we are integrating. It's the pi and the minus pi that's doing it. If we look at multiples, cos x, we're going to have something like this. Right, we're going to get multiples of this. So basically, any of these cos graphs here that integrate between 0 and pi or minus pi and pi, they're going to cancel themselves out. So that's where we end up here. Bit intense, a little bit messy on the board. Hopefully you were able to keep up. All right, but this is where we're going. This is the real crux from there to there. This is the real crux to crux, and we're going to make that the subject of our next video. So, to make sure you don't miss it, like the video, subscribe, and importantly, hit the bell so you know when our follow-up sequel, because on this cliffhanger, I'm just going to say, see you next time.